Hey guys, and welcome back to TBS Skylabs. We're continuing with our series on transistors, and we're trying to make our different logic gates. So last time we looked at how to make an OR gate, which was something like this. And with an OR gate, if either input was 1, then the output was a 1. Today we're going to look at an AND gate, and hopefully this should be reasonably logical. There's one bit that's kind of weird. And we'll talk about that, but most of it should be reasonably similar to what you were doing before. So, where does logic fit in, or where does the AND logic fit in? Well, if you look here, we have a little AND. Okay? And what is that saying? So, it's saying you must be hungry and you must have food for you to be able to eat. So in this case, if we had food and if we were hungry, then the cat would tell us to eat. However, if I change one of these to be false, then what's our cat going to say? He's going to say, don't eat. Okay, so that's the concept of AND logic. It's both things must be true for the output to be true. And in Python, it probably looks something similar to this. So hungry is true, food is false. So we don't eat because if we can't eat, we don't have any food, frankly. Yeah, so sad, but kind of true. Okay, so with that in mind, we're going to try and make an AND gate out of our transistors. Let's give it a go. I'll see if I can set it up. I was having a bit of trouble with this earlier. I think it's okay this time. There we go, that's much better. Okay, so first thing is I'm going to put some power onto my board. Now again, you can probably just plug your battery right into here. I'm going through the board itself here, and I'm just using this to connect one side to the other because I can't find my battery connector. I think it's in the school. So you see the lights on, so my power rails are now good to go. Okay, so this time, and I guess the important thing about this situation is, I should probably tell you what we need first. We need 2 transistors, an LED. Now here we're going to have some weirdness. We're going to have a 220 for our LED. We're going to have a 1K resistor. Now this is the weird one we're going to come back to. And our 2 10K resistors or something similar that we are using to go to the base of our transistors. And that should be all we need. Now, let's set it up. So just like last time, we are going to set up our buttons so that they are connecting in to the transistors. And we, as I said last time, don't necessarily have to have buttons. It could be something more automatic. I hope that LED is not getting in your way. Let's move it. So, doom, and doom, and that should connect into our system. Okay, both of those are going to connect to the positive rail. Positive rail. And a positive rail. And then we want to go from those into our transistors. Now this time with our transistors, we don't want to connect them separately. This time we want to connect them together. So again, if we were thinking about our river, as I mentioned before, our river of electricity or current, our current is coming from positive to negative, and we're going into our LED. I don't know what that is. That looks weird, but that's an LED, okay? At the end. Now, last time we had 2 separate rivers. This time we've just got one river, or one canal, if you prefer, and we are going to have 2 blockers on the way. So, in theory, if I want to get the electricity to here, I have to open both of the gates, or both the transistors. So what's that again? So if this is A and B and X, then A, B, X, zoom, zoom. If they're both off, X is off. If B is on, X is off. If A is on, X is off, because both of them open. And 1, 1, we want to produce a 1. So we're trying to produce that logic. And this gate looks like a kind of like a D. 2 inputs and 1 output along the way. Alright, let's see. So this is our A and B we're making first of all. So let's see if we can find the, hopefully, the correct resistors and stuff, because I've slightly muddled them up, but let's try and see. Oh, I'm missing one. Okay. Let's see. There's the other transistor, and there's the other resistor hiding under the paper. There we go. So, the transistors this time are going to be in what we call series. So the transistors are connected together. Last time they were in parallel, and they were effectively separate. Now, I'm just going to put in a little gate. I'm going to put in a little wire here, just so that you can see that the output of that one is going to then connect to the input of the other. Now, I could fix the legs right next to each other. This is just you can see a little bit better if we have that middle line going on. And again, we want to be able to connect that to the current. So the current should flow through here, into my LED. And finally, it should then go out to the negative. Let's try negative to the negative line. I think that's right. Let me just check. So let's just make sure, is that in the same line? Yeah, so my negative line and again negative side of the LED are going into the ground there. So now, just like before, I need to connect my bits of my buttons together. So I'll try and use the right LEDs. Sorry, I'll try and use the right resistors if I can find them. Now, again, the colors of the LED will tell you what kind it is. And if you're not sure, because I find it really hard to tell the colors apart, I'll be honest. If you're not sure, what you can do is put them into a voltmeter, and that will tell you exactly which one is which. So I generally have to do that because I find it really hard to remember all the different color rules and to actually be able to see the colors, because some of them look really similar. Like I think a 10K and a 330 look pretty similar, and I have a hard time telling them apart just by looking. Maybe your eyesight's better than mine. Okay, now in theory that should all work, but it's not going to. Okay, we're going to find out we actually have a problem here. So okay, if I put A, nothing happens. Yay! Now if I put B, oh, nothing happens, which is good. It's not what I was expecting. So what's going wrong? Oops, I think I've just got that LED leg wrong. There we go. So that should be there. Let's see. Ah, okay, good. So A, when it's a 0 and a 0, should give me a 0. If it's a 1 and a 0, I should get a 0. Now if I do a 0 and a 1, I should get a 0. Uh-oh, that's not working. Even though it makes perfect sense logically as to why things are going that way. So what we need, what's happening here is we're getting like a bit of a fake signal coming through. It's turning stuff on and off. Because really zeros and ones, it can be quite hard to get them perfectly aligned. Now, I find this bit really hard to understand, so if you don't understand it, that's totally fine, because I don't entirely 100% get it. But what we do need to do is just make this signal coming out here a little bit more stable. And to do that, we're going to use a resistor. In this case, I believe it's a 1K resistor, if I can find the right one. And I'm going to plug that into the ground at the same point where the LED is receiving the electricity. Now the aim of this, I believe this is called a pull down resistor, and the idea is just to, there could be extra stuff flowing through here. We're getting too much coming through when we press this one, so we want to try and reduce how much is coming through extra, and we're just giving it a bit of a drain to let it escape. And again, if you don't understand that, it's totally fine. It's hard to get your brain around to that one. But now that I've got my pull down resistor, fingers crossed, if I press this, so now it's not lighting up when I press B. It's not lighting up when I press A. But fingers crossed, when I press both, when it press both, then it should light up. That was me touching the resistor that's causing the issue there. So just to prove it again, nothing from B, nothing from A, but A and B together will give me a 1 out. And that is the same as our truth table over here. And that's how we build an AND gate. Yeah, give it a try, see if you can figure it out. And feel free to ask questions. And we're doing it in class. This is just to help you guys review and maybe give you something to work with if I'm having to deal with too many people at once. And once again, I would suggest if you have multiple boards available to you at home, let's try not disconnect them, because in our final little section we want to think about how we could start combining them together to make some of our other logic circuits as well. Okay, thank you, bye-bye.